Hello. This video gives some guidance on replacing roofs that have been damaged in a wind event in any part of Australia. In almost every case where the roof has been damaged due to wind, the primary cause is more to do with the weakness of the roof and the roof structure than the strength of the wind itself. So after the roof has been damaged is the perfect time to have a look at what is underneath the roofing and make sure that all the tie downs will do their job properly next time the wind really hammers that roof. If the roof hasn't performed well enough already, there's no point putting back the same details. It has to be upgraded. Let's think about the loads that the wind can put on a roof. This 370-ton plane flies because of what happens to the airflow over the wings. As the wing rushes through the air like this, some air gets pushed down by the underside. That gives a little bit of lift. But really exciting things happen on the upper surface of the wing. As the front of the wing pushes air molecules up and out of the way, the wing moves into the space where they used to be. Now there is nothing on the upper surface of the wing. This nothing is actually suction, which lifts the plane into the air. Aerodynamically, the same thing happens to a roof that is stationary while the wind is rushing past it. As the wind hits the house and goes up and over the top of the roof, it sucks out air above the roof, and that creates suction on the roof. These suction forces are highest on the edge and near the ridge of the roof. So those are the areas that need the extra anchorage. Wind can exert several tons of force onto the roof of a house. So if we were only using weight to hold the roof down, we would need to park the equivalent of one or more elephants on the roof in non-cyclonic areas and a whale on the roof in cyclonic areas. Obviously we can't do that, but there are tons underneath the roof and we can tie the roof down using the weight of the whole house. The secret to keeping the roof on is to ensure that there's really good tie down from the roofing all of the way down to the bottom of the house. The roofing must be anchored to the battens, and in most cases that's done really well. These photos show some typical success stories. See how well the roofing is tied to the battens. But then the battens need to be tied down to the rafters or the trusses, and then the trusses have to be tied down to the walls, and the walls have to be tied down to the floor, and the whole house anchored strongly to the ground. The most important task is to tie the roofing and the whole roof structure to the walls. While the roofing is off, it is possible to see what is holding down the battens and the rafters or trusses. And if the existing connections aren't good enough, they can be replaced at that time. In order to determine the tie down required, you need to check the site wind classification for the building, which gives an indication of how fast the wind is going to be hitting that particular site in a design wind event. In some cases, the owner may know the site wind classification from the plans, but if not, you can use the standard AS4055 wind loads on housing to determine the classification. It's particularly important to get this right, because if the tie downs are sized using a classification that is too low, then they will be severely overstressed. So if there's any doubt at all about the correct site classification, it's always wise to use the higher classification. The first step in working out the wind classification is to use figure 2.1 in AS4055, which tells you which region the site is in. For example, Brisbane is in wind region B. The next step is to look at the terrain within 500 metres of the site. Google Earth is ideal for doing this. The most open terrain within the circle is the value you use. For this example, the site is surrounded by suburban lots and all of the land in the circle is terrain category 3. Next, check whether the house has any shielding. 2 rows of houses on all sides are required for full shielding. In this example, there's only 1 row of houses providing shielding on the south side, so it's classified as partially shielded. Finally, the topography has to be checked, and often a site visit is necessary. In this example, the house is on flat land, so the topography classification is T0. All these classifications are used together in Table 2.2 in AS4055 to provide the appropriate wind classification for a particular site. However, As a general rule of thumb, if a house has good views, it's going to have a higher wind classification. The Region B house in this picture would be considered N3 on flat land, but because it's built at the top of a steep hill, it's actually N5. So while you're quoting on the re-roofing job, check the view from the roof. If you have a really good view, you know you are going to have to use substantial tie downs to ensure that the roof is properly secured, which may affect the price of the job. Different site wind classifications require different tie down connections. Also, the highly loaded areas around the edges and ridges require stronger tie downs than the general areas of the roof. For housing, the outside 1200 millimetres of each panel is considered to be an edge region. This takes in at least 2 battens at the eaves and the ridge. You can determine what tie downs are needed from a number of different sources. The roofing manufacturer will tell you the anchorages you need to connect the roofing itself to the battens. Batten manufacturers often specify the connections required for their products to tie them to trusses, and truss manufacturers should give details for tying down the trusses. If these details are not available from the manufacturers, you can use AS 1684 for timber and the Nash standard for steel to match the site wind classification to the loads required. Other tables in the same documents give you the tie downs needed. We have learned from damage investigations that nails on their own don't have enough strength to hold down edge and ridge battens against wind loads in almost any part of Australia. So if you see battens fastened with nails, some extra fixings will be required. Many older roofs have hardwood battens or trusses, so to prevent splitting, it may be a good investment of time to pre-drill seasoned hardwoods before driving any screws in. Also, in coastal areas, the BCA has special requirements for corrosion resistance for all structural elements, including battens and fasteners where they're exposed to the sea air. The client may ask you to change the type of roofing material. For example, sheet roof replaced with tiles or vice versa. Most states and territories require building approval for any change of roofing material. If changing from a light to a heavier material, the ability of the structure to support the increased weight will need to be assessed. However, if changing from a heavy to a lighter material, review all materials and tie downs to ensure that they can resist the wind uplift. There may also be local variations in construction practices that will have to be considered as part of the tie down process. For example, in some cyclone regions in northern WA and some parts of northern Queensland, there may be over-battens on top of the roof sheeting. These have been designed as the main anchorage to tie the roof firmly down to the bottom of the structure. If the over-battens are removed, something else needs to be put in their place that does that job just as effectively. Most of the connections in the roof may also have to be replaced. It is recommended that a full engineering review is conducted if the over-battens are removed. If the roof needs replacing as a result of damage during a wind event, it's likely that some part of the roof structure or cladding has a problem and needs to be upgraded to prevent the same thing happening again. The damage to the old roof may offer enough access to the roof structure to assess which components or connections will require upgrading. But it's still important to advise the client that there may be some additional upgrading costs that only become apparent during the replacement process. As a building professional, you will want to do the best job possible for your clients, and your duty of care is to provide safety and amenity. When all roof connections are checked and upgraded if necessary, you can be confident that the new roof will not only look good, but perform well in strong winds.